Assalamualaikum warahmatullahi ta'ala wabarakatuh. So we continue. Today we need to understand the X-ray diffraction. What is the X-ray diffraction? Okay, so just imagine a lattice of the atoms act like a mirror. So the incoming X-ray hit the lattice and then be reflected to produce the diffraction pattern. Okay, then what is the ideas? What is the X-ray diffraction? Okay, so this one is the diagram to show the simple experiment how to produce the X-ray diffraction. Okay, so here is the X-ray tube. So X-ray tube is the apparatus that to produce the X-ray. Then the X-ray will go through the slit, the single slit here, and then after that they hit the crystal. So the crystal, that means inside here is the atoms. So and then what happened? So they produce the photographic plate. This one in the photographic plate they produce the pattern. So in this case is the diffraction pattern. Okay, this one is the diffraction pattern. Okay, so this one is the simple diagram or the simple experiment to produce the X-ray diffraction pattern. So here is the incoming rays. Incoming rays actually is the incident rays, and then they hit the atom, and then what happened? So they produce the reflected rays. Incident rays, the incoming rays, and then produce the reflected rays, the outgoing rays. And then so in this diagram we understand we have two type of rays. The first one is the incident rays, and then the second one is the reflected rays. So when the incident rays meet the reflected rays, and then after that they produce you the diffraction pattern. Okay, so we continue. So the diagram shows the lattice of the atom. So here is the arrangement of atom. So normally we call as a lattice of atom, or sometimes we call as the layer of atom. So and then here also we have the lattice of atom or layer of atoms, and then the distance between the first layer of atom, the first lattice of atoms, and then the second lattice of atom. So is a distance between the layer or the lattice of the atoms. So we sign D. Okay, continue. So the outgoing rays would interfere with another to give either constructive interference or destructive interference. And then we can saw from the photographic plate, so the type of the diffraction. So diffraction pattern here. So what we can saw here is the pattern is like this. Okay. So we have the black dot, black dot, black dot, black dot, and then that one is constructive interference, and then for the black one is the destructive interference. But for our lesson today, we just need to understand the constructive interference. Okay, we continue. So with the constructive interference, So to produce the constructive interference, so the reflected rays, incoming rays, where ray 1 and ray 2 must be the same phase. Okay, so to get the constructive interference, that means the rays, the reflected rays, where ray 1 and ray 2 must be the same phase. So ray 1, ray 2, this one is the incoming or the incident rays. So here is the reflected rays. And then to get the constructive interference, that means the reflected rays, ray 2 and then the ray 1 must be in the same phase. Okay, so we continue. Therefore, to get the ray 1 and then the ray 2 in the same phase, the path difference of the rays must be equal to the n lambda. So here is the constructive interference. We focus on constructive interference. Different paths of the rays is equal to the n lambda. This statement we get from the optic physics. So to get the constructive interference, that means they must obey this principle. Different paths of the rays equals to the n lambda, where n is an integer. So the integer, they start from 1, 2, 3 and so on, where lambda is the wavelength of the rays. Okay, so consider ray 1 and then the ray 2 here. Okay, so we focus on this diagram. Okay, so focus on the ray 2 first. We focus on ray 2. So the ray 2 propagate and then they hit the layer of the atom, and then after that the ray 2 is reflected. So if we focus on the ray 1, now we focus on the ray 1. So what happened to the ray 1? So the ray 1, they go through and then hit the second layer of the atom, and then after that the ray 1 is reflected. Okay, so in this case, the difference between the ray 2 and the ray 1, the ray 1 need extra distance to go. So that means if the ray 1 they move from here and then reach here and then they reflected, but ray 1 they have the extra pass. That means they have the extra pass AB and the BC. That means the different pass of the ray 2 and the ray 1 is the AB and then the BC. So that's why we have to find the different paths between ray 2 and ray 1. That means we have to find the AB and then the BC. Okay, so here is the AB, and then here is angle theta. Of course, here is the theta. So from the sine theta is equal to the AB over D, then we can get the AB is equal to the D sine theta. Clear? Okay, then now we have to get the BC. BC here is a BC, and then here is a theta. Then is a theta, of course here is a theta. So we can get this diagram. Then we can find the sine theta is equal to the BC over D. Therefore we have the BC is equal to D sine theta. Now we can get the AB, and then also we get the BC. So we continue. Therefore the different paths of ray 1 and the ray 2 is the AB plus BC, and then equals to the n lambda. So of course we already known the AB is equal to the D sine theta, then BC is equal to the D sine theta, and then D sine theta plus the D sine theta, we have the 2D sine theta, and equals to the n lambda. Then we can write the equation as 2D sine theta equals to the n lambda. So that means this one is the equation known as a Bragg equation. So where d is the distance between the atomic layer or the atomic lattice, theta is the angle between the ray and the atomic plane. So be careful, theta is here. Here is the atomic layer, and then here is the ray. So that means the theta is from the ray relative to the atomic layer. Theta here is not here. The theta is here. N is the integer, so they start from 1, 2, 3, and so on. And then the last one is the wavelength. Lambda is the wavelength of the ray. Okay, and then hope we understand how to get the Bragg equation, and then we know how the process of the diffraction of the X-ray. Hopefully you understand. And then until now, thank you.